The volume of oil in a cylinder container, a cylindrical container, is increasing at a rate of 150 cubic inches per second. The height of the cylinder is approximately 10 times the radius. All right, so we've got a cylindrical container, so something like this. And it's being filled with oil, so it looks like maybe something like this. All right, so there's some liquid oil in here, and let's say there's a little faucet and oil's going in at a rate of, so that's the change in volume, dV dt. So the volume is changing at a rate of 150 cubic inches per second. And then we can talk about the radius of the cylinder and the height of the cylinder. Okay. At what rate is the height of the oil changing when oil is 35 inches high or 35 inches deep? At what rate is the height of the oil changing? Okay, so that's telling us to find dH over dt when H equals 35. All right, so we need a relationship between volume and height, because we know change in volume and we're looking for change in height. So we need to relate these two variables. We need the V and the H to be related to each other. All right, so we have the formula for volume of a cylinder. It's the area of the base, pi r squared, times the height. Well, the problem here is there's a third variable we don't need. We don't need the r. So we need to relate the v and the h, and that will allow us to relate the dv dt and the dh dt. All right, so at this point we have to eliminate the r. But we're given this, the height. The height of the cylinder is approximately 10 times the radius. Okay, so we also know that the height is equal to 10 times the radius. So we have these two equations, the equation that relates the variables v, r, and h, and the equation that relates the r and the h. So we want to get rid of r, so let's solve this equation for r. So the radius, if we divide both sides by 10, the radius would be h over 10. Okay, so we could take this h over 10 and plug it in for this r, thus removing r from the equation. All right, so volume equals pi times the radius, which is h over 10, squared, times h. Okay, so there's our formula. Now we have a formula or an equation that relates only the two variables whose rates of change we're interested in. All right, so let's simplify this. Volume equals, well, h squared over 100 if we square this. So it looks like pi h, and then there's another h here, so that's h to the third power over 100. Or if you want to write it, maybe pi over 100 times h cubed. It's another way you could write it. That way we would take the derivative. It's a little more visually apparent what's going on. All right, so now we understand the problem. So step one, identify the quantities that are relevant to the problem. Sketch a picture. Anytime you could draw a sketch, it's probably a good idea to draw a sketch. And then we've related the quantities. Now, step 3. Introduce the rates of change. So we have to take the derivative with respect to t of the entire equation. All right, so derivative of v would be, let's switch colors because we're switching to derivatives. So dv dt is equal to pi over 100 times the derivative of h cubed, which would be 3h squared times dh dt. So don't forget the times dh dt, we're using implicit differentiation. We're taking the derivative with respect to an external variable, time. All right, so once we've taken the derivative, now we can plug in the given values. So dv dt is given. That's 150 equals, well, let's say 3 pi over 100 times h squared. Well, at the moment when the oil is 35 inches high, so that would be 35 squared times dh over dt. All right, so let's simplify this a little bit. Let me just break out the calculator. 35 squared is 1,225. And we'll multiply that by 3. Okay, so 150 is equal to 3,675 pi over 100. So that's the 3 over 100 times 35 squared. So that gives us 3,675 over 100, and that's multiplied by pi. And of course, that is times dh over dt. And now let's multiply both sides by the reciprocal. So 150 times 100 is 150,000. And that's going to be divided by 3,675 pi. Okay. And that is dh dt. If we want to reduce that fraction, yeah, we could probably do that. I'm going to bring over the graphing calculator. So 15000 divided by 3,675, and we'll convert that to a fraction. So 200 over 49 pi. Is our value for dh dt. Now remember, this is the rate of change of the height at the exact moment when the height is 35 inches. If the height is 40 inches, there's a different rate of change. Okay, that about does it for this problem.